We are absolutely surrounded by documents, patents, research papers, legal contracts, and they're packed with brilliant ideas. But let's be honest, they're just flat. They just sit there. But what if you could take the knowledge that's locked inside and actually make it do something? What if you could turn a wall of text into a living, interactive simulation? Well, that's the incredibly powerful idea we're going to dive into today. So take a look at this. This is a real US patent for a device that detects epileptic seizures. And like millions of other patents, it's basically a wall of text and diagrams. It communicates an idea, for sure, but it's fundamentally a static, unchangeable document. You can read it, but you can't really interact with it. But here's the game-changing question. What if you could take all the logic locked inside this document and just execute it? What if you could turn this patent into a living, breathing simulator that you could actually test and explore? Okay, so here's our game plan. First, we're going to unpack why these static documents are even a problem. Then we'll see the magic behind turning that text into a simulator. We'll watch a real patent come to life, see what it can actually do, and finally, we'll look ahead to a future where pretty much all knowledge could become executable. Now, to really get why this is such a big deal, we've got to start with the core problem. And it's something the creators of this framework call the structural gap. So this gap, it's the fundamental disconnect between the knowledge described in a paper or a patent and our ability to actually use that knowledge with a computer. All that brilliant logic, all the rules, the constraints, it's all just trapped in the text, which means we can't really put it through its paces. You know, think of it this way. A blueprint can tell you how an engine works, but you can't turn the key. The knowledge is right there, you can read it, it's communicable, but it's not operational. And breaking down that exact barrier is the entire goal here. So how in the world do you bridge that gap? Well, that's where the DBbun methodology comes in. It's a systematic way to turn that static text into a working simulator. The core idea is actually really simple but so powerful. It's that every structured document, whether it's a patent, a research paper, you name it, it already contains all the necessary ingredients to become a simulator. It's got entities, variables, and rules just sitting there, waiting to be extracted and, well, activated. Now, this isn't some custom, one-off hack they built for just one patent. This is a repeatable pipeline. And the key here is that it's domain agnostic, which is just a fancy way of saying the same six-stage process works whether you're analyzing aerospace plans or simulating biological signals. The whole process is incredibly logical when you look at it. It starts by essentially reading the document. Then it pulls out all the key rules and logic, builds a formal model, and sets up the boundaries for the simulation. Only then does it run the simulation, making sure every single action respects the original document's logic before it gives you a validated, structured result. All right, let's get to the main event. Theory's great and all, but let's see this thing in action with that epilepsy detection patent we saw at the beginning. This right here is the transformation. On one side, you've got the input, a standard static PDF document, and on the other, the output, a complete executable companion. And this isn't just a summary, it's a whole package with a runnable simulator, synthetic data, and all the figures ready to go. And here is where you can really see the difference. On the left, that's a simple, flat chart right from the patent. It's just an illustration. But on the right, that's a rich, dynamic three-axis signal that was generated by the simulator. It's not just an image, it's data brought to life, created entirely from the logic described in the patent's text. And this is so important. The simulator isn't just generating random noise. It creates super specific synthetic data for the exact scenarios mentioned in the patent, from actual seizures to everyday movements like typing. This lets you rigorously test if the detection logic actually works. So this brings us to the real payoff. What can you actually do with this executable thing? Well, it's all about interactive decision support. So instead of just reading about how the system should work, you can now see it in action. This chart shows the simulated seizure probability for each of those 6 scenarios. You could immediately see how the system's logic tells the difference between something like typing and a real seizure. The patent's claims are no longer just words on a page. They're testable hypotheses. And we can go even deeper. This plot visualizes the decision boundaries of the model, separating seizure events from other motions based on their signal frequency and amplitude. I mean, this kind of insight is nearly impossible to get from the static text alone. It makes the internal logic of the patent visible and really understandable. Okay, this is all technically very impressive, but does it actually help anyone? Like, do the engineers and researchers who use this kind of information find it valuable? Well, the answer seems to be a resounding yes. This executable companion was published on IEEE Dataport, which is a big platform for researchers and engineers, and it received a perfect 5 out of 5 rating across 20 different votes. That's some strong evidence that turning a static document into an interactive tool isn't just a neat trick, it's a genuinely valuable resource for the people who really need to understand this tech. So this one patent is a powerful proof of concept, but the real vision here is so much bigger. This is not about one-off projects. It's about building scalable infrastructure for executable knowledge. And you should know, this isn't just some clever piece of software. DBbun is a full-on technical architecture, and it's backed by 3 separate patent applications of its own. They cover everything from the data engine to the compiler that turns the patent into a simulator. This is truly foundational technology. This means that the process we just saw isn't a one-time magic trick. The goal is to build an automated pipeline, a kind of factory that can take in any patent and quickly spit out its living executable companion. It turns a slow, manual analysis into something fast, scalable, and repeatable. Now, let's think beyond just engineering patents for a second. Imagine applying this to other dense, rule-based documents. You could simulate the economic impact of antitrust regulations before they're passed. You could model different outcomes in a complex bankruptcy case. You could stress test intellectual property claims to find their weaknesses. I mean, this becomes a powerful tool for decision-making across the entire legal and policy world. So the big idea I want to leave you with is this. We started with a single patent, but the destination is an infrastructure that can unlock the active operational knowledge that's trapped in millions of documents. It fundamentally changes the question we ask. We no longer have to stop at, what does this document say? We can finally ask, what does this document do?